apple, tree, bat. These things must have come to your mind as I said these words. Well, every language is a set of words which represent something meaningful. Algebra is also a language in mathematics. Just like English is a set of letters which combine to form words and sentences that represent something meaningful, algebra contains variables which combine to form meaningful expressions. Variables are used to represent anything unknown. It may be age, it may be price, it may be quantity. These variables are represented as letters, and when these letters combine with operations, they form expressions. But the actual puzzle is that which word in English stands for which operation. We know that in English, more than one words may have one meaning, so we cannot assign a single word to an operation. We cannot assign just one word to addition. There are many words which represent addition, like these. Similarly, there are many words which may mean subtraction. There are many words which represent multiplication and words which represent division. So we need to know which word actually represents which operation. Now what do you do when you learn a new language? You translate words or sentences in your known language to the new language. So let us now try and translate sentences into algebraic expressions. Tom had 17 DVDs. He bought D more DVDs. So how many DVDs does he have now? Well, if I tell you that Tom had 17 DVDs and he bought 2 more DVDs. So how many DVDs does he have now? You'll tell me 19. How did you reach the answer? You added 17 and 2. So here also, Tom had 17 DVDs and he bought D more DVDs. So we need to add it to find how many DVDs does he have now. If the statement is Tom had 17 DVDs and he added D DVDs to his collection, then Tom had 17 DVDs and he added D DVDs to his collection. So it is the same thing, 17 plus D. Tom had 17 DVDs. He increased his DVDs by D. So how many DVDs does he have now? 17 plus D, because he had 17 and he increased it by D. So it is 17 increased by D or 17 plus D. So we see that more, added to, increased, all these words represent addition operation. So 17 plus D, it represents the addition operation. It can be stated as 17 plus D, 17 added to D, sum of 17 and D, 17 increased by D, a gain of D over 17, and a total of 17 and D. So all these words represent the addition operation. In fact, there are many more words which represent addition. As you practice more and more, you will come to know of more and more words which represent addition. Now we need to find the age of John's son. John is X years old. 25 subtracted from his age gives his son's age. So we have 25 subtracted from his age. And it is given that his age is x years. So 25 subtracted from x gives his son's age. So we need to subtract 25 from x. So 25 subtracted from x. X minus 25. This is the age of John's son. Now John is x years old. The difference between his age and 25 gives his son's age. So the difference between his age is given to be x years. So the difference between x and 25 gives his son's age. What is the difference between x and 25? X minus 25, which is the same as this. So the age of John's son is x minus 25. John is x years old. His son's age is 25 less than his age. So 25 less than his age. That is 25 less than x. What is 25 less than x? 25 less than x will be given by x minus 25. So the age of John's son is x minus 25, which is the same as this. So we see that all these words, subtracted from, difference between, less than, all these words represent the subtraction operation. Note that in some cases, the subtraction operation works backwards. So 25 subtracted from x, that is 25 subtracted from x is not this. It is x minus 25. It works backwards. Similarly, 25 less than x is not this. It is x minus 25. So these words represent the subtraction operation, and in some cases the subtraction operation works backwards. So x minus 25, it represents the subtraction operation. It can be stated as x minus 25, 25 subtracted from x, difference of x and 25, x decreased by 25, and 25 less than x. So all these words and many more words represent subtraction operation. So let us solve a question now. Identify the operation to be used. A decreased by 2. So we have studied decreased by stands for subtraction operation. So this is A is decreased by 2. So A minus 2 is the answer. So the operation to be used is the subtraction operation. Now we need to find the price of apples. What is given? Given that the price of oranges is P and the price of apples is 2 times the price of oranges. So it is 2 times P. So 2 times P is 2 into P, and it can be written as 2P. So the price of apples is 2P. Now the price of oranges is P. The price of apples is 2 multiplied by the price of oranges. That is the 2 multiplied by P. So we have 2 into P, which again gives us 2P. So we see that times multiplied by, all these words represent the multiplication operation. So 2P represents the multiplication operation. It can be stated as 2 times P, product of 2 and P, 2 multiplied by p. All these words represent the multiplication operation. The quotient of y and 13. Now when we have to find the quotient of two numbers, what do? We divide the first number by the second number. So this is y divided by 13. And we have already seen it can be written as y by 13. So it is y by 13. Now if we have y divided by 13, then again it is y divided by 13, which can be written as y by 13, which is the same as this. So we see that the words quotient, divided by, all these words represent the division operation. So whenever we have these words, we understand that we have to divide a term by another term. So y by 13 represents the division operation. It can be stated as y divided by 13, quotient of y and 13, ratio of y and 13, 1 by 13th fraction of y. So these are all the words which represent division operation. As you will practice more and more, you will learn many words which represent addition, subtraction, multiplication and division, and you will come to know how to use them.